Welcome! In this video, I'd like to talk about the confidence intervals for the population mean mu with the standard deviation sigma unknown case. A confidence interval is a range of estimates for unknown parameter. We are going to estimate the population mean mu in this video. The confidence level is a percentage of certainty that confidence intervals would contain the true population mean mu when we draw a random sample many times. Common confidence levels include 90%, 95%, 98%, or 99%, with 95% being the most common. Here is the illustration showing what a 95% confidence interval means. Suppose the true population mean body temperature is 36.32 Celsius degrees. I constructed a confidence interval as between 36.27 and 36.51 by sampling as shown. Then I constructed another interval using the same sample size showing as second line. I repeated sampling with the same sample size to get 20 confidence intervals. As you can see, one of the intervals does not include the population mean, but the other 19 intervals out of 20 contains the population mean. This is a true meaning of a 95% confidence interval. Each interval does not show a probability of 95% as you can see. Each interval has either 100% probability if it contains mu, like the first interval, or 0% if it does not. We use this criterion to decide which table we need to use. We focus on the population standard deviation sigma and if it is known or not. I'd like to show an example for the sigma unknown case in this video. In such cases, only the sample standard deviation S is given in the example. If sigma is not given, after checking the second condition, we use the t-table and t-formula to construct confidence intervals. We'll go over both of them in the next two slides. Here is the t-table we'll be using. The first column shows the degrees of freedom, which we can find by subtracting 1 from the sample size. The top row shows the confidence level. The intersection point of these rows and columns gives the t-scores in the body of table. I'd like to stress here that the population mean value itself is unknown. However, there are two ways to estimate the population mean. The first method is point estimate, and the other is called an interval estimate. For the point estimate, the sample mean x bar is employed as the best one. For the interval estimate, we find the interval or range of values using the formula shown. E stands for the margin of error. In the formula, we can find a sample standard deviation S and size N easily in the question. As for finding t-critical values, we use the t-table. If you need more practice finding t-critical values, please watch a separate video called Finding T-critical Values for Confidence Interval Sigma Unknown. Let's look at an example. Before looking at each question, we need to determine which distribution need to be used as a pre-step. We always find 3 numbers in the main question text. So identify each number with symbol first. For 52 patients, if the number is associated with a random sample of, then this refers to the sample size n. For 6.8 days, it is clearly stated as mean coming from the sample of 52 patients. Therefore, it is a sample mean x bar. The last one, standard deviation, is the most important piece to determine whether to use Z or T distribution. If you read the question one more time, the sample of 52 patients record gives a mean 6.8 days as well as a standard deviation of 8.2 days. So 8.2 is the sample standard deviation. Some of you may be wondering how to distinguish the type of standard deviation from population and sample. Here is a quick guideline. If you find the mean and the standard deviation together in one sentence, then that one is most likely the sample standard deviation, since one sentence provides the information from a sample. If a standard deviation values is provided in a separate sentence, then it is most likely the population standard deviation sigma. In this example, since sigma value is unknown as the first condition, it is most likely t distribution that need to be used. However, let's double check the second condition. We have the sample size greater than 30, therefore, we can decide on the t distribution to be used for this example. Question A. Please remember that the best point estimate for the population mean is the sample average. So the point estimate for the population mean is the sample mean of 6.8 days. Question B. Construction of the confidence interval for the population mean mu. Since we already decided to use t distribution for this example, here is the formula. In order to use the formula, we already have x bar, s, and n values in the main question. So we only need to find the t critical value by changing 95% confidence level, which is the center area, to one-dimensional value of t-score. You could use the easier notation t sub c for the critical value. To find the t critical values, we need 2 values. 1. Identify the given confidence level, 95% for this question. 2. Find the degrees of freedom by subtracting 1 from the sample size 52 patients to get 51. Then look up the table using these 2 values. We need to find the t-score for the confidence level 95% and the degrees of freedom 51. First, locate 51 degrees of freedom. However, we cannot find 51. In this situation, use the next lowest number, 50. Then, select 95% confidence level from the top row. The intersection of those is the t-score 2.009. We use the next smaller value 50 as the degrees of freedom since 51 is not in the table. Now we have found a positive critical value 2.009. However, we should have the negative t critical value as well. So plus or minus 2.009 are the critical values for the 95% confidence level with a sample size of 52. We have just found the T critical values plus or minus 2.009. Here, I have just listed the positive T critical value since the first formula has a plus and minus signs for calculations. Once we have found the critical value, organize all 4 values in preparation for the next step. Again, you can use the T sub C notation for the T critical value instead of the above notation. Here are the formula and organize the values. Step 1. Calculate the margin of error. Substitute the critical value standard deviation on the numerator and the sample size inside of the root symbol to get 2.28450 and so on. If there are no specific instructions in the question, round it to the same number of decimal places as the mean. In this question, it will become 2.3. Once we have value for the margin of error, we use the interval formula. For the lower limit value, calculate x bar minus the margin of error we just found. Similarly, calculate x bar plus the margin of error to get the upper limit value. The lower limit is 4.5 and the upper limit is 9.1 as calculated. Then simply place the lower value on the left and the upper value on the right of inequality notations. Please do not forget to place mu in the center of inequalities. Question C. Interpret the result in question B, focusing on the population mean mu. Start with a consistent phrase, we are some percent confident that, and go back to the question sentence to complete the interpretation. Here is the question B slide. Recall that we are looking for the 95% confidence interval for the population mean length of stay of surgery patients in the hospital. This part implies the population mean mu, not the average length of stay for just 52 patients. We simply copy this part to explain mu. We make use of the question sentence to write the interpretation. Please include the phrases population or all patients in order to include the mu, and make sure to use a singular verb as the mean is a single value. I hope this video has helped you in understanding estimations for the parameter mu. Questions, comments, and suggestions are all welcome. Thank you for watching. See you again.